Today I'm going to talk to you about the OWASP top 10 risks for open source software. My name is George Apostolopoulos. My background is in engineering. Most of my career I've focused on building tools that help security professionals, initially for enterprise security, later application security, and hopefully developers as well. I'm doing the talking today. A lot of this is based on a work from my colleague, Henrik Plate, that he couldn't come today. I will present some highlights of the top 10 open source OWASP project, and then I'll leave a few minutes at the end for questions if you have questions and you want clarifications. First of all, open source is very important. I don't know if we want really to present too much data to support it. I think it's kind of obvious. I have a few data points here in some studies around the Census 2, which is a set of popular Java open source projects. About 85% of the code was actually open source dependencies, and there were quite a lot of these projects that had more than 80% of their code was open source, right? So definitely open source is everywhere. And as we all know, when you use open source, you accept certain risk. It's kind of buyer beware. There is no guarantee provided by the owners or the developers of the software. If you're familiar with OWASP and top 10s, you probably know there are quite a few of top 10s, right? So the question here is that why do we need yet another one? Especially because there is the OWASP top 10, the main one. There is the A06, which is actually capturing the risks of open source dependencies. But we believe that first of all, dependencies are very important. Open source is really very important. And there is a lot of nuance, a lot of details that may easily get lost if we don't break it down a bit more. So that's why a couple of years ago, the top 10 OWASP risks were created after discussions with 20 CISOs and other security professionals. And we hope that this captures a little bit of the detail and the nuance that comes into the open source software. And there is no time to dig deep into all of this today, so I'll highlight a few of the ones that I believe are important and interesting. And then there is a lot of material online, so we can go and look at more details. In this list, if you look at it quickly, you'll recognize some of the things that you expect to be there. For example, known vulnerabilities. Everybody's familiar with vulnerabilities and vulnerability management. Licenses, common issues. But there are a lot of other interesting things like untracked dependencies, under and oversized dependencies that most people may not be familiar. So these are some of the things I will highlight today. Again, vulnerabilities is probably the most common problem with open source. Everybody worries about vulnerabilities. So there is some issue with the code, accidentally included there. We mostly care about the known vulnerabilities, not the 0-day. And some of them may be fixed. Some of them may not be fixed yet. Some of them may have active exploits. And the risk is very clear, right? I mean, somebody may use this vulnerability to compromise my software, my engineering environment, my credentials, right? I mean, there is a known risk that comes from these ones. And the actions to mitigate that risk, again, it is you need to somehow keep track of these vulnerabilities. You need to scan your code and other assets. You need to be able to figure out accurately what kind of assets do you have, right? Because when it comes to open source dependencies, even determining accurately which are the dependencies you are using is not always easy. There are many ways to include these dependencies in your code, and we'll see some of this later on. So you need to have a good inventory to know how many vulnerabilities you have. And then most of the cases, you're going to have too many, right? Because you use a lot of open source has issues, a lot of vulnerabilities. So then it becomes a prioritization game, right? I mean, I need to quickly focus on what is more critical, more risky, more important for my own environment, so I can start fixing the serious problems first, right? And there is the CVSS, CPSS, there are all mechanisms and metrics that are available in the industry to help with this prioritization. And here on the left, you can see a little bit the life cycle of vulnerabilities. Now, when it comes to determining if a particular vulnerability is important for you, right, then you have to see exactly how do you use this, or how this vulnerability shows up in your project, in your own open source dependencies. I know this image is probably a bit too small to see in detail, but pretty much there is a complex graph that essentially you get built, because at the very top there it is, you see at the very top is your project. Then you directly import some dependencies, some open source projects. That these open source projects, they have their own dependencies, so they create this kind of graph of multiple levels of dependencies and open source. And somewhere down here it is the actual this vulnerability, and then you have to kind of make sense out of all this and see that if this is actually used and how important it is and how exactly it affects me that I'm sitting up here, right? Which is already a complex problem. And to make it more complex, but also more interesting, is you can start looking at the function granularity. Because in this case here, I was looking at the package granularity. So I'm importing a particular open source package that then imports another open source package, right? So these nodes you see in the graph here are packages, right? Now, a package can contain thousands of functions inside, right? And the vulnerability, eventually, it will be in one of these functions. It's not really at the package level. So now I go one level down, and then I get into this very beautiful picture, but also very chaotic, right? I mean, in here, the green dots are actually functions of my own application, and all the other dots are functions in open source packages that I'm using, and the links between them is actually the invocation, right? So starting from a green dot, I can call another function that can call another function, then another function, another package, and down somewhere there is a vulnerability, right? So this definitely adds tremendous complexity. On the other hand, adds a lot of visibility that can be very useful for understanding exactly how I'm using open source dependencies, if I'm using any sensitive APIs in my dependencies, what happens if I upgrade dependency, if something will break or not, right? So this enables a lot of use cases. Probably the more impactful one is if I'm actually vulnerable to a particular dependency, right? Because in this example here, again, at the green dots at the top is my own code. And these are the calls I'm making to some vulnerable software. And at the very, very bottom, there is actually a vulnerability that affects one particular function. So if I have this information and I know how my code calls this function, or if it even calls it or not, right, then I can determine if I'm actually vulnerable or not. Because in this case, you see there is a path from my code to the vulnerable function at the bottom. So that means I have this vulnerability, so I have to address it. But it could be that the vulnerability will be on some of the other nodes, which I'm not directly calling. In this case, it's not like I don't have to worry about it, but I can deprioritize and I can say I'm going to fix this later, right? So this is the power of the call graph analysis. But again, there is a lot of complexity because even the scale, as you can see here, is actually high. And another thing, when we talked about call graphs and its ability, is it's important to know which is the function that is actually, that has the vulnerability, right? Because many times vulnerabilities are announced and are described in NVD or other sources like OSV, right? But it's not always the information that where exactly this function is that has the vulnerability is not always available. Sometimes you have to go and analyze the fix, and then by looking at the fix of the vulnerability, you say, oh, yeah, that's the function that had the problem, right? But this information is not widely available. So, and it's something that is often overlooked, right? So having the call graph and having this detailed information on what functions call other functions, it's one part of the problem, but the other problem is I need to also have a good database of vulnerable functions. So these two can work together to tell me when a vulnerability is actually affecting me or not. And building a comprehensive vulnerability database that has all this granular information is actually pretty hard. So it's a significant engineering effort. And there are quite a few open source databases, but they're usually incomplete, or they need to be correlated carefully because they sometimes contain conflicting information. So that's one kind of risk, right? Vulnerable packages. Now, another interesting risk is the compromise of a legitimate package. So I'm using this very popular open source dependency like many other projects. Everything is fine, but one day, for whatever reason, this particular open source package gets compromised in the sense that somebody somehow manages to inject some malicious code, right? And now this can be extremely dangerous because usually there is a certain amount of trust when I'm importing open source packages. I expect them to be as advertised and they're not going to be malicious. So if this happens, then a huge amount of the open source ecosystem can be compromised, right? And this can be a very important attack vector, right? And it's sometimes hard to defend because exactly of this implicit trust, right? And then, of course, if somebody manages to get into my environment through this compromised package, then it can do a lot of damage. Typically, all these attacks take steal keys or other access tokens, so they can attack my infrastructure, right? And they can do a lot of damage. This is actually quite difficult to track, right? Because if you think of the attack surface, let's say I'm an open source developer and I'm actually building some very popular open source package, right? I mean, the attack surface for me is huge, right? Somebody can send me a phishing mail to steal my credentials. Somebody may compromise my system at home. Somebody can do a social engineering attack, right? So attacking me as a software developer of a popular open source is like an enterprise attack, right? So all the attack vectors you can think attacking an enterprise apply to individuals, right? There were stories about blackmail. There were stories, or some other times what happens that a developer kind of retires or stop working on a project, then somebody who is malicious takes over the project, right? So there is a huge and very complex attack surface, and a very good resource here is the Risk Explorer here, number 2, that actually has a nice graphical taxonomy of all these possible attacks. So this will give you an interesting overview of the complexity of the problem and how difficult it is to defend. So what can I do to defend? There are some solutions. The most important thing is to do some kind of version pinning or log files. That means that every time I build my software, I don't automatically upgrade to the next version, right? I mean, in some ecosystems like NPM, it's very common to say every time there is a new version of a package, automatically get it. That means that if somebody manages to compromise and produces a new bad version, I'm going to automatically get it. So in order to improve my security posture, I should not do that, right? So this is called pinning or log files, so that frees my dependencies. A more drastic solution is to build from source. That means vendor these dependencies. In this case, I have complete control. On the other hand, this kind of defeats the purpose of having open source because I kind of assume all the risk and all the effort of developing this in-house by vendoring it, right? Another common sense validation is to have digests and signatures, so at least I can verify that the open source that download is actually what it claims to be and it's not hijacked. And of course, there is a lot of scanners where can be used to kind of check a package for malicious contents. Another one that is also interesting is the unmaintained software, right? So many times, especially if I have a lot of projects, I end up including or depending on thousands of other packages, and then over time, some of these packages become unmaintained. Essentially, the developers of the packages move on, something happens to them, they lose interest, right? I mean, and of course, when this happens, it's very hard for me to tell because everything keeps working on my code, there is nothing breaking, right? On the other hand, when something problematic happens with that package, or they say there's a vulnerability that is found, this vulnerability may never be fixed because the maintainers are not available or they're not interested anymore, right? So in that case, over time, I accumulate risk, right? And of course, that risk will show up when there is a vulnerability, one of these packets that has not been fixed, then I will get compromised, right? And there were quite a few of these cases happening, especially the Gorilla Web Toolkit was a very popular open source package. Once upon the maintainers came out and said, okay, guys, we cannot really continue developing this, we're leaving it, right? So then this kind of caused a lot of concern in the industry because it's very popular, it's very critical, but on the other hand, you know that it's not going to be maintained. And in this case, I think the developers did the right thing and they came and they said in public that, we cannot, for certain reasons, continue maintaining it. In other cases, this happens silently, right? So what can you do to protect is to actually have tools that give me this visibility. So at least I know that, out of my 10,000 open source dependencies, there are these 5 or 6 that are not really actively maintained. And in this case, I have some options to maybe switch to a different package that is maintained, maybe vendor it in this case, right? But at least I know what I'm getting exposed to. And a good example of a well-maintained project is the Spring Boot. So you see there is a kind of a logical progression of maintenance over time. So the green is when it's actively maintained, and the yellow is when you can get extended maintenance, right? But you see all projects over time, they get stale, So either a project is actively maintained and the maintainers keep producing newer versions, or at some point this will stop and then you're stuck with some old obsolete versions. Untracked dependencies is another interesting case, right? Because it's important if I want to evaluate my risk and eventually mitigate it, I need to have a very clear image of which are the open source packages that I'm using, right? So in some cases, this may sound easy because, yeah, if you have a Python project, you have a way to say these are the packages I'm including, right? But that's not always the case because there are many ways where I can end up importing or depending on packages that are not in the standard way, right? So an example here is a little bit extreme maybe, but there is an example here on a Python code where, in this case, on the fly, dynamically in my code, actually I'm figuring out which package to import, right? So in this case, not only the Python YAML package that I'm importing is not even in any kind of manifest, so not only I cannot find it there, but it's actually runtime. The behavior will be determined at when my program runs, right? So it's almost impossible in some cases to do it properly. So in this case, for example, I will not even know with most tools that I'm importing this Python YAML. So if there's something wrong with Python YAML, I won't even know, right? So the mitigation here is try to, essentially in this case, you need tools, right? I mean, there is no way to manually review these cases, so you need tools that have the ability to actually figure out these cases where I'm doing this, or example, rebundling, that's a hard word to say, but that's another common issue, right? So for example, a lot of Python packages, for example, they contain some C++ generated binaries that they're done like this for performance, and these binaries are actually repackaged in many, many other Python packages. So now, at the top level, I'm using a Python package. Deep inside, there is actually a C binary which can be used in many places, and most tools, they will fail to make this connection, right? So if there is something wrong with this C binary, I won't even know at my Python level, and something very similar exists in Java as well, where a lot of jars are rebundled, right? So even something which at the high level will appear simple, like, okay, fine, I have this project, and this project has 10 open source dependencies. It's actually not that simple, right? I mean, there could be a lot of corner cases, and even having an accurate list of these dependencies is actually quite challenging. And the last one is the undersized, oversized, which is actually something that is easy to overlook, but it's actually quite important, right? So, for example, you have in some ecosystems like NPM, it is very common to have extremely tiny little libraries that do one small thing, right? So this actually is convenient, right? So instead of, let's say, doing something like a map or something like this, I can import a small library that can do it for me. That's all very nice. On the other hand, by importing this tiny library, I'm getting exposed to all the open source supply chain risk, right? So what happens if somebody compromises the developer of this little library? So somebody takes it over and uses to inject vulnerabilities and malicious code in my environment, right? And there were a few cases where actually this happened with some tools that people used in CI. So the fact that the convenience that comes with, okay, I'm not going to write 15 lines of code, I'm going to import this library, my life is good, comes with a risk, right? And slowly people become more and more aware of that risk, right? So very small libraries or undersized dependencies could be an issue because I get a lot of risk for 10 lines of code, and this trade-off may not actually be worth it. The other side of this coin is that I have a huge dependencies, right? So maybe I need something specific. Maybe I use some library to do logging, but then maybe this library comes with a Kubernetes component that actually brings a tremendous amount of other dependencies for Kubernetes, which I will never need. I don't care about my code, but I'm stuck with it, right? Because it comes with this huge library. So this library is going to bring thousands of dependencies, which I don't really need, and this, again, will increase my attack surface and my risk. So in this case, it would be very nice if I could say, you know what, I have this huge library, but maybe, or package, so how about I split it into 3 pieces and I just keep the one I want, so I minimize my risk, right? So this trade-off of functionality versus risk, I think it's something that people slowly become more and more aware of as the attacks in open source have become more popular and people pay attention. And there is a lot of opportunities for tools that can help here, but this is something which is, at this point, more at a research level because people are not even looking at these nuances yet, right? I mean, it's more at the level of what is vulnerable and how I can fix that, right? But this is some of the emerging things that people will actually start understanding more as they become more aware of the risks of open source. Then there will be ways to figure out this trade-off between convenience and risk. And part of this is actually the visibility into packages, right? Because now, for example, when you import a package, of course, you know what the package is doing, which is fine, but then you don't know other information. Like, for example, does this package do any network calls? Does it do any operating system calls? Does it do something else, right? Because if this package is doing network calls, then it can introduce behaviors and risk in my environment that a package that doesn't do network calls will not do, right? So there is a lot of differences if you compare packages that have the same functionality, and if you start looking at what they do inside, probably there will be a huge range of packages that do only what is advertised and don't do anything else, and packages that do a lot of network calls, a lot of things that can improve or increase the risk. So you see there are a few frameworks that are actually trying to do this, right? There is the concept of sensitive APIs. So there are some projects that actually look at specific dependencies and see what is actually the sensitive APIs you are using, and some examples that are spawning processes, using cryptographic functions that could be assigned that are probably doing something with crypto, do they do network connections, do they write to the disk, do they read from the disk, right? So this information that will give you more visibility on the risk of packages, right? And there are some different other projects that are doing this as well. So again, that was a very brief overview of few of these top 10 risks, right? What's next is, like all these top 10 projects, it's important to collect feedback from practitioners and understand more how people feel about these things. Again, this list came from discussions with CISOs and network security practitioners, right? So it does kind of reflect the thinking, but it's always very important to collect more information and more data. A lot of these top 10 lists are data-driven, so coming with feedback from the community, we can figure out, what is more important and less important, what needs more or less attention. Some of these cases, we don't even have good metrics to evaluate the risk. Right, so for example, I have a vulnerability that maybe is reachable, maybe is not reachable. What is the risk exactly? Some cases we don't even have good ways to actually measure that risk, right? And of course, there is a lot of room for tools, right? Because we talked about call graphs, which is one class of visibility and tools that you need there to deal with this. We talked about oversized and undersized dependencies, which again, we are going to need different tools to figure out, what is the risk compared to the benefit I get from reusing the code. So there is, like many other areas of cybersecurity, there is a lot of need for tools to support security professionals and developers in this case to do better, right, and reduce the risk, right? I mean, what is interesting here is that different than previous stuff I did in previous jobs that has to do more with enterprise security, and the consumer and the target of the tool was actually the security professional. A lot of the things we do here also target the developers, right? Because this is very developer-driven, and developers have their own requirements and their own criteria to like a tool or dislike a tool, right? So that's it. If you have any questions.
We have a few minutes for questions. Anybody has some? No questions?
Yeah.
Can you suggest some tools for the I don't remember what you called it now, for the overuse of dependency or the
right, the
functions were used in a dependency?
That's the area that is actually less mature. So I'm not even sure there is a tool out there that does it, right? There is some of the tools that do this call graph analysis. They have the ability, because they are going to tell you that, this dependency has 300 functions, but you use only 20 functions. So they give you some rough metric, right? But I don't, honestly, at this point, I don't know if there is a tool that actually captures that part, right? There is the function leverage ability, something that is happening in the industry. Slowly, you see more and more vendors supporting some forms of it, right? But nobody has done this yet, right?
Thank you.
Any other questions? Well, thank you, George.
Yeah, thank you very much.